two Polaroid lenses. When they're perpendicular to each other, it doesn't allow any light to pass. So we have the light here coming through, and when they're parallel to each other, you can see the light. When you cross them, it shuts out the light. And then when you put a singly refractive stone in it, it turns around and nothing happens. If you put a doubly refractive stone in it, then as you turn the stone, it lets light through because it twists the light, and so it blinks. I don't know if you can see that or not, but so this is a doubly refractive stone. That narrows it down probably to a blue topaz or an aquamarine. Well, let's just see if this one's doubly refractive. Yeah, so this one blinks too. So it gets dark, then it gets light when it twists the light, and it comes through parallel to the top lens because it's twisted perpendicular to the bottom lens. So these are both natural gemstones probably because of their double refractivity. And then this is called a refractometer. If these are blue topaz or aquamarine, they'll either be 1.58 or 1.62. The blue topaz is 1.62, the aquamarine is 1.58. They have birefringence, but in many cases, unless the polish is good, you can only get a spot reading, which is just one reading, and it'll be around 1.58 and around 1.62 with some play on either side. The double refractivity would make it like 1.57 something to 1.58 something, and then the same with the blue topaz, probably 1.62 something. I think it's still 1.62 something, but different. 1.621, 1.629.
So birefringence
is how much the two rays of light are split when they go through the stone.
I see.
And so there's different amounts of birefringence. It can be very slight or very great. Blue zircon, these aren't blue zircon because blue zircon has a very high birefringence, and when you look through the stone, you can see double. It splits the light so much when you look at the back facets in a blue zircon, you see double. And so you don't really need any of these instruments with a blue zircon because you can see it with your naked eye. So in order, this has a very high, this glass is very soft and very fragile, has a very high refractive index, so it does most stones with the exception of diamonds and CZs and things like that, but most other color stones it will do. And then you need this liquid, which is very toxic, to make contact between the stone and the lens, and it's a very, very small amount that you need. This gives you just regular light. This is so you can eliminate any background light. So this is this is a spot reading, let's see here, 1.618 to 1.62 something. So this is a blue topaz. Then you wipe the liquid off very carefully for a number of reasons, but also off the lens when you're finished because it'll eat at the lens. So this guy here, let's see what's going on with it. So this is an aquamarine, just as you predicted.